You want to play with OpenAI's API from Node.js but don't know how? No worries. The genie of the AI lamp will fulfill your wish. Let's play. Let's start playing with OpenAI APIs from Jupyter Notebook. Please refer to our previous video for the Jupyter installation. Some prerequisites first. We first declare a function to execute shell commands. Then we need to install some useful NPM modules, like ESM hook to import and use ESM modules, .env to manage environment variables, the official OpenAI libraries for OpenAI, and the LangChain Framework in its JavaScript version. So I use the sh function that I just declared before to install all these packages. We also need a security key to access to the OpenAI API. So I have an account on OpenAI and I stored my key in a .env file that is stored in the same folder as this notebook under the GPT key entry. So I need to load the key in my execution environment by running this code. So I do require the .env package and then I load the config. And this is just a test to check that my key is properly loaded. So let's run it. Here, the key is loaded. Right. There are many possible abstraction levels when communicating with LLM, large language model, starting with direct API calls that we could make, for instance, with curl. At level 1, we can also use binding libraries in Node.js, or leverage more abstracted frameworks for generic commands and processes. We can also use no or low-code solutions at level 3, and even rely on all-in-one application providing both backend and frontend to final users. In this tutorial, we'll visit the first 3 levels. Let's start with level 0 of abstraction, that is direct API calls. So OpenAI APIs, the main ones, are completion API, where the user sends a prompt and then the model completes the text by generating a relevant and coherent content. But it's being deprecated now and it's replaced by chat completion API that is designed around the concept of multi-turn conversation. So it's possible then to have a memory of the conversation that we have, that we had with the model in a chat, and then be more contextualized. Another important API is embeddings. Embedding is the mean of the model to transform text and meaning of the text to vectors, mathematical objects that can be processed. And it's the capacity of determine the distance, the semantic distance between 2 sentences, 2 phrases, or 2 documents even. All right, so let's start with chat completion API. Here what I do is I use the fetch command and generate fetch command from Node.js just to call the API here. So the URL is here, it's api.openai.com, and I'm calling the chat completion API in version 1. In the header, I put the key, my security key that I got from my .env file. And then in the body, I send an object, a JSON object, and giving the name of the model that I want to use. Here is GPT-4. And the message, the context. So here there are 2 messages. The first one is the raw system, and I tell the system the context on how it is supposed to behave. So you are a helpful assistant here. And then is the content, the question asked by the user. So please say hello in French. Then I wait for the answer to be sent back, and then I navigate through the object to give the relevant part of the answer. So let's execute this code. And then here's the answer. So with the role of assistant, the LLM just answer bonjour, which is correct. Being French, I know that's true. So now let's use the Embeddings API. So basically it's the same structure. I just changed the name of the model that I want to use, the API, it's Embeddings, and the name of the model that is text embedding ADA, which is the embeddings model of OpenAI. Then the encoding format, because remember it's vector mathematical object, so I want floats. And the input, the text, the piece of text that I want to transform into vector. So let's execute now this command. And then here we are, the answer. So you see a number of vector. Basically, it just displayed the 100 first, so it's 1,536 values. So it's a large vector representing the meaning of this text. The GenAI's lamp makes your wishes come true. So that's nice, and that's what is expected from OpenAI, because that's the dimension of the vectorial space of the embedding model. We can also use other API. I just illustrate one here, is image generation. So we call the DALL-E 3 model this time. And I want also to illustrate the fact that in a Jupyter notebook, you can also have access to the way things are displayed. So here I create a variable image, and I use this command just to create a new object in the notebook, a new cell that I call image. Then I am calling this time this image generation API, still with the same API key. The model now is DALL-E. I just want one image. This is the size of the image, and this is the prompt describing the image to the model, this time DALL-E. So I want a robotic genie coming out of a magic lamp. All right, and then I navigate, and I know it's plain old JavaScript, I mean HTML with not a lot of JavaScript here, but I just want to take the URL of what is returned by the model and then display it inside the notebook by using this image object that I created before. All right, so let's execute also this code. So you see here, the promise is here. It's taking a little bit more time because now the model has to create and generate the image. So let's wait a while and discover what DALL-E created for us. Wow, this is the GenAI's lamp stuff. Maybe I should change the logo. All right. Okay, interesting. So that was level 0 of abstraction. If we move up the abstraction ladder, then we can go to level 1. So level 1 is by using the OpenAI official library provided by OpenAI. All right. So to do that, I do require the OpenAI library that I installed before, you remember at the beginning. And I will use two different objects. The first one is the configuration. And basically what I do here is, again, I get the key from my file and I pass it to the configuration object. And then the OpenAI API object with the configuration object passed as parameters. And then I'll be able, by surrounding the asynchronous call to the API within an asynchronous function that I call run completion, to be able to call the create chat completion. And I pass the same kind of parameters as before, like the name of the model, GPT-4 here, and the message. So the same ones. You are a helpful assistant, but this time I ask a different question. Why is the sky blue? And again, I navigate into the response object to just display the relevant part of the return object. So let's run it and discover what's going on. Then here is the result. The sky appears blue, whatever. This is the explanation. If I run it a second time, you see the answer is slightly different. I mean, it's the same meaning. They still speak about the scattering effect and the ray life scattering cause and stuff. But you see, it's not the exact same answer, proving that LLM are not deterministic computing. Okay? So it's very interesting, and there are other API available in OpenAI to deal with videos, to deal with sounds, text to speech, speech to text, but it was just to illustrate the fact that things are not only textual here. Let's move on now to level 2 of abstraction with the LangChain Framework. So LangChain is a well-known framework. Okay, that offers abstraction level, so it's easier to do complex things with fewer lines of code. So let's do chat completion again, but this time with the LangChain framework. So I do require from the LangChain library the OpenAI chat model and the human message format. So again, then I use the chat OpenAI object, I instantiate it, and then I pass the security key and the name of the model to the subject, and then I'll be able to create first new message. So this time I just use a single term message. Basically, I will use a prompt that is passed as a parameter to this get chat completion function, and then call for the API and wait for the result and display it. And now let's call the get chat completion function, and how to say hello in Swahili, for instance. So it's Jumbo, and again this time how to say it in Swedish. Hash. All right. Now with embeddings, so let's use LangChain embeddings object also. So we do require it, and then we create an OpenAI embeddings object, and same thing, the GPT key. This time the model name, you remember, is text embedding ADA 002, and then I just have to call the embeddings embed query. So the tech squad is a Worldline DevRel initiative, and I'd like to know how does it transform into a vector, embedding vector. So let's run this code also. And then, again, we have this 1536 dimension vector that is returned. So you see, easier, more abstracted level of coding. But what do we do embedding, by the way? So how useful can it be? It's used, for instance, in a retrieval augmented generation pattern that is called RAG. RAG is a way to inject context to a question that we ask to a LLM, all right? So you see a LLM was pre-trained by OpenAI, if we're speaking about GPT-4, on a large data set. And then when an AI assistant is asking questions to the LLM, the answer is based on this general knowledge that was pre-trained and pre-learned, let's say, by the model. All right. When we want to customize, to personalize the LLM and the answers that is making, one way of doing it, instead of fine-tuning the model and changing basically the way it's trained or specializing the training of the LLM, we can also, at runtime, inject some contextual information in the prompt that is sent to the LLM for the LLM to take into account the contextual information that we sent and mix it with his general knowledge and make a more contextualized answer. The interesting part here is those contextual datasets are never sent to or kept at least by OpenAI, so we have to deal with them ourselves. And those data can be stored as vectors, as embeddings. So a way to implement the RAG pattern is to store embeddings of some local document, local information. It can be website, document, any source of data or information. We convert that into vectors, embeddings. We store them into vector stores. And then at one time, when a user will ask a question to the LLM, will also transform the question into a vector, and then a semantic research here to find the most relevant, at semantic level, the most relevant chunk of data in our contextual data set to inject them into the prompt that is sent to the LLM and to have a more contextualized answer. All right, so let's try to implement basically at very basic level this RAG pattern. So before doing that, we will do it with a single PDF document for sake of simplicity of this tutorial. So we will use the embedding API, but first we have to split the document into chunks, then call the embedding API for each chunk, then get each chunk, which is a vector, and store it in a local database. As I said, it's called a vector store, and then use also the embedding API to transform in a vector the question from the user, make the semantic search, and then call the LLM and get the answer. So it's a lot of actions, of different steps in this chain of treatment, the chain of processes, and this is where LangChain is very useful, hence the name, LangChain, because it will help us to automate and abstract all these different steps. So let's see how it goes with this piece of code, for instance. What I do here, I will use in-memory vector store that is provided by LangChain, but we can use many other vector stores like persisted vector store, specialized vector stores like Chroma or Quadrant, but it can be also PostgreSQL, for instance, with the PG extension it's installed. Anyway, as soon as you can deal and do the semantic research on vector. Here, I will use the in-memory local database. So that's what I'm doing here, importing it from the LangChain library. Then I also use the PDF loader. That is an object that provided by LangChain that will ease the way of accessing to the PDF content and then cutting it into chunks and retrieving the important information. And I will use a retrieval QO chain that, as I said, is implementing all these different workflow, different steps to do implement the RAG pattern. All right. So let's look first. What we do, we load the TechSquad PDF file. Basically, it's a PowerPoint presentation that I did convert into a PDF file. So let's load it, and then use the vector store object, the memory vector store object that we imported earlier on, to chunk the document and embed that in memory. And then I can use the retrieval QA chain object just by passing the chat. So the chat, you remember, for previous code is the access to the model, and then use the vector store as retriever to get the context. And then you just have to make the call. So call to the chain, and the query will be what are the ambition and objective of the TechSquad. So I expect the answer to this question to be contextualized. Let's see how it goes here. So here you can see the promise that is being executed, because basically what is being done here is a lot of operation behind those few lines of code, because it's the whole RAG pattern that is being run. Okay, and the LangChain framework is now loading the document, chunking it into different pieces, asking the OpenAI embedding model to convert that into vectors, storing the vectors in my in-memory vector store, then taking my query here, also calling the embedding model to get the vector corresponding to the semantics of my question, and then making a semantic search with this vector to get the most relevant vector from my memory vector store, and then final call, the prompt that is sent to the GPT-4 model with the original query and the most relevant vector to get a contextualized answer. All right, so let's wait and see what answer is provided. Oh, it was. Okay, so the ambition of the TechSquad is whatever. So there's a mention of Worldline here, which is my company. So I know that is coming from my TechSquad.pdf file, because the GPT-4 model was not trained of that kind of information. So the RAG pattern and the use of LangChain in a few lines of code is very easy to implement a first level implementation of RAG architecture. Then, of course, if you want to have more efficient, more precise, more quality in your answers, you have to work on the document themselves, on the quality, or also on the way how to transform the documents into vectors, and maybe add some metadata, relevant metadata that we will use also when we query our vector store. But for the purpose of this tutorial, that's enough. And you see that with a few lines of code, we're able to do that. All right, so that's all for today. And in a future video, we will visit the level 3 and level 4 of abstraction. So remember how to use first no or low code solutions to discuss with OpenAI, and maybe in another video how to use some all-in-one application to do the same thing. And that's it for now. Keep making wishes, and maybe the GenAI's lamp will fulfill them. Stay tuned. Bye-bye.